Good morning, students. So in this class, I will going to talk about CPU and other aspects of the computer. I have shared the screen. So in the previous classes, we have discussed computer generations, computer types, bit, bytes, and words. These concepts have been discussed in the previous classes. Today, I'll start with central processing unit. Central processing unit, it's also the extension is CPU. Its extension is central processing unit. It's called a central processor or the main processor or just the processor. CPU is the electronic circuit within the computer that executes instructions that take up a computer program. The CPU performs basic arithmetic, logic controlling, and input-output operations specified by the instructions in the program. CPU has evolved from a bulky vacuum tube-based unit of the 1940s to a modern 5 cm square chip. Today, its size is around 5 cm maximum. That is commonly called the microprocessor or simply the processor. In the previous classes itself, I have discussed about the CPU roughly. Today, I'll talk about the CPU and other parts in depth. CPU includes arithmetic logic unit, control unit, special purpose registers, and clock. Okay, the circuitry includes ALU, which does all the arithmetic and logical operations. Okay, it includes control unit. Control units generates the signals from time to time so that the processor can able to accomplish its specified tasks in time. CPU circuitry also includes special purpose registers like stack pointer, PC. PC stands for program counter, which contains the address of the next instruction to be executed. It includes other special purpose registers. And apart from special purpose registers, there are GPUs called by the name general purpose registers. General purpose registers are used for storing the data temporarily during the execution of the program instructions. They aid, they assist, they help us in storing the temporary data and the results in between the processor calculations. Intermediate results can be stored temporarily within the general purpose registers. Special purpose registers cannot be used for storing the intermediate results. They have to be used for specific purposes. That's why they are called by special purpose registers. Apart from special purpose registers, processor includes GPUs, general purpose registers. It also includes a clock for timing purpose. Okay. Okay, let us discuss about the parts arithmetic and logic unit. Arithmetic and logic unit is a super calculator. After all, let's see, CPU, it's a faster calculator. It does, apart from calculation, it does many things. Okay, that's why we are behind computers. The calculations are so faster. It performs integer arithmetic, compares two numbers, performs Boolean operations. Okay, the two states what I have discussed in the previous class is 0 or 1. Boolean means like true or false, on and off. Okay, such operations like and, or, not, and so on. Okay, basic operations, digital operations, and for example, bitwise calculations like what is 1 and 1? 1 and 1 is okay. Uh, sum is 0, carries 1. Okay, 0 plus 1, sum is 1. 1 plus 0, sum is 1. 0 plus 0, sum is 0, carry is also 0. OR operations, OR 1 or 0 is 0. 0 or 1 is 1. When both the bits are equal to 0, the result is equal to 0 in case of OR. Not means if it is 0, if it is a not operation, okay, not of 0 is equal to 1. Not of 1 is equal to 0. Okay, reverse, opposite bit we will get as output. So arithmetic and logic unit, it's a super calculator. It does all the arithmetic and logical calculations. Then comes the control unit. The control unit is a component of the CPU that directs the operation of the processor. Control unit, that is CU, does not perform any computational tasks. Sorry, it tells the computer's memory, arithmetic and logic unit, and input-output devices how to respond to the instructions that have been sent to the processor. Okay, it controls and coordinates the activities taking place within the CPU, but it does not perform any computations by itself. Both arithmetic and logic unit and the control unit use the services of a clock for sequencing and synchronizing their operations. What do you mean by synchronization? Understanding between control unit and ALU will help uh, to perform the calculations in a very good manner. Okay, so special purpose registers. The CPU uses few high-speed registers to store the current instructions and its data. One of the registers called the program counter, as I have explained in the previous slide, PC, it's called by the name PC. Okay, it's called program counter. It stores the address in primary memory of the next instruction to be executed. It stores the address of the next instruction to be executed in advance. Okay, there are other special purpose registers. One of the registers it's mentioned here, one of the special purpose registers mentioned here, it's called by the name program counter. Apart from the program counter, there are also other special purpose registers, okay, available. So if you are computer science students, you are going to learn about all the special purpose registers, their task, okay, and what is the work of each special purpose register in subjects like computer organization, advanced computer architecture. In such subjects, you're also going to learn about okay, of course, apart from computer science students, electronics engineering students will also going to learn about these aspects because they have subjects related to these. The clock. The CPU cannot execute more than one instruction in one clock pulse, even though one instruction may take several clock pulses to execute. Okay, thus the faster clock, the faster is the execution. Okay, it may take each instruction, it depends on the instruction. The instruction may take more than one clock pulse. Okay, clock pulse. Don't compare the clock pulse, the clock rate of the CPU with the actual clock what you use. Okay, that's different. Okay, that's used for the clock inside the CPU. It's used for generating the clock pulses for sequencing and synchronization of operations. Okay, these are the main building blocks of the CPU. Okay, ALU, control unit, special purpose registers, and clock. Next, let's talk about memory. Memory is an essential resource used by the computer and its users. CPU needs memory for the currently running program. Users need memory to backup programs and data that are not needed currently. There are two types of memory called by the name primary memory and secondary memory. So in one of our previous classes, I was talking about like whenever I use the word memory alone, it means that I'm talking about primary memory. Primary memory means RAM, random access memory. Okay, so during the execution of your program, all the program instructions and data have to be loaded into primary memory for execution. Okay, if your program is loaded into memory for execution, only then CPU considers your program for execution. Okay, so but once you switch off your computer, the program loaded into primary memory will going to be erased. It's not a permanent storage. Permanent storage is being secondary memory like hard disk. I'm going to talk about these aspects. Look at memory. There is a diagram. Sorry, excuse me. There is a diagram figure given in the bottom of the slide. Okay, memory. That's a memory. That's a RAM chip, and that's a chip being used. Primary memory. Again, let us talk about primary memory. Its categorization, the types of primary memory. Okay, all about it. Let us talk about it in detail. Primary memory stores instructions. Primary memory includes, it's primary memory means RAM. Again, in RAM, there are two types, SRAM and DRAM. SRAM means static RAM. RAM means random access memory. Why it's called random access memory? Probably it takes same amount of time to access any part of memory. Okay, so it has two types. SRAM. SRAM stands for static RAM, random access memory. DRAM stands for dynamic random access memory. Okay, so read only read only memory. ROM stands for read only memory. Okay, uh, sometimes boot up whenever you are like booting your system, whenever you switch on your system. Okay, uh, your system, okay, has to load the operating system into memory. Okay, so Booting purpose is assisted. Booting process is assisted with the help of the instructions stored in read-only memory. Okay, the program is called by the name Bootstrap program. A small program called by the name Bootstrap program. Bootstrap program is loaded into read-only memory. Read-only memory, it's a small memory. It's you can only read. You cannot. Most of the time, it has other versions that I will talk about later. Okay, in this class, random access memory. It's very small. A small program normally called Bootstrap program is loaded into it. Whenever you switch on your computer, that program runs first, then it loads the operating system from secondary memory to primary memory and initializes all the remaining aspects of the aspects of the system as well. Okay, so read-only memory, it has different types of different types. PRAM stands for programmable read-only memory. You can program. Okay, the whenever read-only memory is manufactured, sometimes it comes blank. You can program. Okay, so and other forms are EEPROM, erasable, programmable, read-only memory. You can erase the content stored in the ROM and you can reprogram. Okay, you can erase the program and you can reprogram. You can put one more new program, EEPROM. EEPROM stands for electrically erasable programmable read-only memory. The first E here stands for electrical. Okay, the memory is erased by passing the electrical pulses. Electrically erasable programmable read-only memory, EEPROM. ROM is read-only memory. PRAM means programmable read-only memory. EEPROM stands for erasable programmable read-only memory. EEPROM stands for electrically erasable programmable read-only memory. Okay, so then comes cache memory. Okay, cache memory. Look at within parenthesis, within bracket. Okay, it's been mentioned that L1, L2, L3. L stands for level. Level 1 cache, level 2 cache, level 3 cache. Then fourth one is CPU registers. Okay, let us talk about cache memory before that. L1 cache, L2 cache, L3 cache. L1 cache, normally it's part of the CPU. We know CPU includes arithmetic logic unit. It's a small chip. It's a small chip within its size is measured in inches. It's a small circuitry which has to accommodate arithmetic and logic unit, control unit, special purpose registers, general purpose registers. Okay, space is required for these things. Okay, you cannot accommodate a big memory. That's why a small cache memory is included inside the processor chip. Okay, so L1 cache, it is called by the name level 1 cache. Normally L1 cache is part of CPU circuitry. Outside the CPU, you can insert L2, level 2 cache, level 3 cache. Okay, it depends on the vendor, it depends on the manufacturer, it depends on the design, how and where the different levels of memory have been incorporated. Okay, new systems normally have more than one level of cache memory. Level 2 and level 3 normally are inserted outside the CPU. Why they have to be inserted outside the CPU and why it's required? Normally cache memory, it's part of CPU. If you want cache memory, it's a small, fast memory. its implementation technology. It uses RAM, SRAM normally. Okay, if it's a DRAM chip, it uses DRAM chips normally uses capacitors. They will going to lose their charge. Okay, because of their leakage process. DRAM chips will going to, the DRAM chip cells will going to lose their charge. Cache memory uses SRAM technology for its implementation. Its cost is more. That's why a small cache chip is included, not only for the cost purpose. Size also matters because CPU has to accommodate, as I quoted, CPU has to accommodate ALU, control unit, special purpose registers, etc. That's why the cache memory size should be very small because it has to be accommodated within the space available. You cannot insert a bigger sized memory within the CPU. Okay, so whenever uh, central processing unit searches, we'll call it as fetch. Instruction execution cycle includes 4 steps: fetch, decode, execute, and write back or save. Fetch, decode, execute, save, or write back. These are the 4 steps. Whenever you want to execute your program, CPU first searches for the program or program instructions in the cache memory. If the processor can able to find your program and for program instructions within the cache memory, then access time is very small, and you can able to execute your program in less amount of time. If the required instruction, if it is not available in cache memory, then the processor will going to search for the instruction or the data in main memory. Again, the size of main memory, it's definitely bigger than cache memory but smaller than hard disk. Probably if for example, if you can able to load 10 programs into hard disk, you can able to load probably 4 programs into main memory. It's an example I'm talking about. This are not the actual figures. Okay, if you can able to load 10 programs into hard disk, you can able to load 3 or 4 programs into main memory. You can able to load only 1 program into cache memory. Look at the sizes. The size is going to be decreased whenever we come from secondary memory to main memory and main memory to cache memory. If your central processor cannot able to locate the required instruction in cache memory, then the required instruction or data is going to be searched from main memory. Okay, from main, if the required instruction and data is available in main memory, then that is loaded into the processor for execution. At the same time, the same instruction or data is also going to be loaded into cache memory, because the next time whenever the processor searches for the same instruction or data, it expects the data or the instruction to be available to it very quickly. The closest memory is cache memory. Okay, because the processor cannot depend on the registers, because the number of registers available are very few. That to each register is capable of holding only one word. Okay, so processor searches for the instruction in cache memory. That's why whenever the instruction or the data is loaded from main memory into the processor, a copy of it is also loaded into cache memory. Okay, if the required instruction is not available in main memory, then it searches in secondary storage memory like your hard disk. It needs to bring the program from hard disk to main memory and from main memory to cache memory. Then it executes. Okay, so since the space availability is very small inside the processor, a small amount of cache memory is included. Cache memory's inclusion will help processor to improve its speed, because because repeatedly executed instructions are normally going to be loaded. Okay, during such time, if the processor can able to find the instructions quickly from cache memory, then its access time reduces. If the access time reduces, then definitely the time taken to execute the instruction or the whole program is going to be reduced. You'll feel that okay, the processor is executing your program very faster. Okay, so if there are more than one levels of cache memories, here for example it's written L1 cache, L2 cache, L3 cache. Let us say L1 cache is part of the processor, L2 cache is outside the processor. In that case, processor first searches for the instruction or data in L1 cache. If it is not available there, then it searches in L2 cache. Okay, L2 cache is normally somewhat bigger than L1 cache. If it can able to find the instruction over there, then it is loaded into CPU. A copy of it is also loaded into L1 cache. If it cannot able to find the required instruction or data in L2 cache, then it searches in primary memory. I mean RAM, random access memory. It's bigger, definitely it's bigger. Then it loads the required data and instructions into the processor, and at the same time a copy is also loaded into cache memory as usual. Okay, then comes the processor registers. It has two types: general purpose registers and special purpose register. One of the special purpose register, having discussed in the previous slide, is program counter, and stack pointer is one more important. Instruction register IR holds the instruction to be executed. These are all special purpose registers. Apart from that, it also includes general purpose registers for storing the intermediate results in between the computations. Okay, because special purpose registers cannot be used for storing the intermediate results or for any other purpose. So all of these memory units: random access memory, read-only memory, cache memory, CPU registers. Okay, so all of these memory units are housed on the motherboard of the PC. The fastest ones are included in the CPU itself, while the relatively slower RAM is outside the CPU. Look at the type of memories. If you come from 1 to 4, point number 1 to 4, 1, 2, 3, 4 have been listed in the slide. If you come from 1 to 4, the size decreases, cost per bit increases, access time reduces. The time taken to access the data and instruction reduces. If you come from 1 to 4, if it is reversed, I mean, if you are going from 4 to 1, I mean from CPU registers to random access memory, if you are going in the reverse direction, then cost per bit means, what is memory? Memory is, after all, it's a collection of different cells. Each cell is capable of holding one bit of information. Okay, so if you are going from point number 4 towards point number 1, cost per bit reduces. Okay, access time, it's definitely increases. The time taken to access the data, it increases, because the memory will go, speed will going to be reduced because of its implementation technology. And one more thing is, the size is going to be increased. You can store more amount of data because the cost per bit is less. Okay, so all these are part of primary memory. Whatever I am discussed, the same thing is included here. Random access memory stores the code and data of the currently running program. RAM loses its contents. RAM, random access memory, primary memory. Look at it, loses its content. Whenever you switch off the computer, it loses its content. And that's why it's called by the name volatile, volatile. It's volatile. Volatile means it will going to lose its content when the computer is switched off. RAM can be accessed a lot faster than secondary storage. In general, the time between primary memory and the CPU is 7 to 10 nanoseconds. Allows storage and random access to data and instructions. Any part of RAM can be accessed in uniform amount of time. Each instruction and piece of data in the RAM has a unique address. I mean, in one of our previous classes, I mentioned memory, RAM. Okay, memory is byte addressable. Each address has a unique address. Each location has a unique address. RAM is fast. It's volatile. Volatile means the contents are going to be erased when the power supply is taken out. When your computer is switched off. That's why it's called by the name non-volatile. Secondary memory is RAM is called volatile. Secondary memory is non-volatile. Non-volatile means permanent. Volatile means when the computer is switched off, its contents are going to be erased. RAM is fast, volatile, and more expensive than secondary memory. RAM can be broadly divided into two types, as I mentioned, static and dynamic. SRAM and DRAM, static RAM and dynamic RAM. Static RAM uses multiple transistors for each cell to store one bit of information. Look at, to store one bit of information, it uses multiple transistors. Therefore, it takes up more space than dynamic memory, which uses one transistor and a leaky capacitor for each cell. Okay, so each DRAM, dynamic RAM cell, uses one transistor and one capacitor. Capacitor will going to lose its charge, and because of its leaky leakage process, okay, it needs to be refreshed. Okay, the charge in the cell has to be refreshed from time to time. That's why the cost per bit in case of DRAM, it's smaller compared to the cost per bit of an SRAM cell. Then comes read-only memory. Read-only memory is non-volatile. Okay, RAM is volatile, means it will going to lose its content when the computer is switched off. But ROM, read-only memory, is non-volatile. Non-volatile means even when the computer is switched off, it will going to retain its content. The content is not going to be erased. That's why it's called non-volatile. Okay. And it's used to store programs permanently. The computer cannot store anything in this type of memory. Okay. In modern PCs, usually used for firmware in CPU. Okay, ROM is an example for firmware. Okay, you have probably heard of the names hardware, software, and okay, hardware, software. It's a set of instructions, program. Hardware means like your monitor, keyboard. They are part of hardware. ROM has characteristics which suits in between. It comes in between hardware and software. It's called by the name firmware because its characteristics fall in between software and hardware. That's why it's in between them. It's called by the name firmware. Okay. In modern PCs, usually used for firmware in CPU, graphics card, hard disks, etc. Many ROM modules are replaced with flash modules nowadays. BIOS means basic input output system, firmware modules to allow easier updating. There are three types of ROM. They are PROM, programmable read-only memory. EPROM stands for erasable programmable read-only memory. EEPROM stands for electrically erasable programmable read-only memory, as I've already explained. Cache memory. Okay, let's go through it once again. The computer also supports cache memory to hold. Just a minute. Sorry for the inconvenience. I'll continue. Cache memory. The computer also supports cache memory to hold those portions of a program that are frequently used by the CPU. This is a fast but small memory. It's available as a buffer between CPU and RAM. Look at the location where cache memory is located. It is located between CPU and RAM. When executing a program, the CPU first looks for the instructions and data in the cache. This was already explained. Modern computers support multiple levels of cache. CPU itself contains level 1 cache, which is the smallest and fastest cache of the system. Level 2 cache could be located outside the CPU, but though L2 cache could be located outside the CPU, but it should be closer to the CPU because whenever the CPU looks into the instructions and data, it must able to access it faster. So that some CPUs also support a level 3 cache, which is lower than L1 and L2, but faster than RAM. Look at whenever you go from N1, L1, L2, and L3, L3 is slower than L2. L2 is slower than L1. L1 is faster than L2. L2 is faster than L3. Okay. L3 is definitely slower than L1 and L2, but faster than RAM. If data is not found in L1, the CPU looks for it in L2 and then in L3. Cache memory is expensive, so they are limited in size because of its cost. Okay, its size is limited. Then let us talk about registers. The small number of ultra-fast registers integrated into the CPU represent the fastest memory of the computer. Each register has the length of the computer's word. Each register, I mean, it's capable of storing one word of data. We know the length of one word. It was explained in one of the previous classes. The length of the, I mean, if it is a 32-bit machine, what is the length of one word? 4 bytes. 32 bits, okay, is equal to 4 bytes. So the length of each register is equal to one word. It can be 16 bits or 32 bits or 64 bits. It depends on the machine. So the register of the Intel i7 is 64 bits wide because it's a 64-bit machine, 64-bit version machine. The computer loads an instruction and its data from main memory to registers before processing them. Okay, registers being very few in number, the number of registers available are very few. Processor cannot able to depend on only the registers because the number available is very less and they are numbered. The program instruction specifies these numbers. Okay. Consider, for instance, the multiplication of two numbers represented by pseudo instruction. Okay. Look at R1, R2, R3. R1, R2, R3 are the registers, and this is an instruction. Okay. Multiplication of two numbers. This is called pseudo instruction. R1, R2, R3. Okay, multiplication. Two numbers are multiplied. Okay, two numbers are available in two registers, R1 and R2, and the result is stored in the third register and R3. Two numbers available in the two registers, R1 and R2, are going to be multiplied, and the result is stored in R3. Let us talk about secondary memory. The computer also supports secondary memory. Okay, it's also known as auxiliary memory. Secondary memory is non-volatile. I mean, whenever you switch off your computer, the contents are not going to be erased. It's a permanent storage, and thus it meets the requirements of offline and long-term storage. These devices are slower than primary memory, but they have larger capacities. They're also way cheaper than primary memory. 1 GB of hard disk space is much cheaper than 1 GB of RAM. Look at the comparisons. 1 GB of 1 GB space of hard disk, it's cheaper than 1 GB space of RAM because of the implementation technology, okay, of hard disk and primary memory. The cost per bit, the cost of each cell, it's different in case of RAM and in case of hard disk. Few of the secondary memory are, look at the hard disk including the portable disk, 500 GB to 4 terabyte. If you have purchased new machines, it's normally it's in between these sizes, 500 GB to 4 TB. GB means what? Gigabytes. TB means what? Terabyte. And we have seen the sizes in the previous classes. Magnetic tape, 20 terabyte. CD-ROM, 700 MB to less than 1 GB. DVD-ROM, it's 4.7 GB to 8.5 GB. Blu-ray disc, look at its sizes, 27 GB to 50 GB. Flash memory based on the electrically erasable programmable read-only memory, it's in between 1 GB to 128 GB. Okay, obsoleted. Floppy disk, it's not available now. Okay, when we were students, we were using floppy disks for carrying our projects and other information or data. The sizes were in terms of MB, 1.2 MB, 1.44 MB. We were using 1.44 MB normally. I think I still remember. Floppy disk, like your pen drives. We were using floppy disks. Okay, floppies are now obsolete. They're not uh, available in the market now. You are using a CD-ROM or DVD-ROM or pen drives. Okay, or today we have other repositories available. You can keep your data in the drive, Google Drive, or cloud, wherever, for sharing purpose. Hard disk. Hard disk, hard drive, or fixed disk because it's fixed inside the computer. The hard disk represents one of the oldest, most commonly used forms of secondary storage. Hard drive is an electromechanical data storage device that stores and retrieves digital data using magnetic storage and one or more rigid rapidly rotating plotters coated with magnetic material. A hard disk drive includes, I mean, it is divided into, it looks like a round shaped plotter, okay, which is divided into tracks, and tracks are divided into the sectors. Hard disks have very high capacities with the cheapest cost. You can store huge amount of data, but the cost per cell is smaller because of the implementation technology. It's common for a laptop to have 500 GB of storage. Desktops usually have 1 terabyte of storage. Then comes magnetic tape. The basic technology has not changed, though. The tape is made of a plastic film with one side coated with magnetic material. The entire mechanism comprising two spools, okay, and the tape is encapsulated in a small cassette or cartridge. Current technology supports capacities of 1 TB or more. Data are read from and written to the tape using a read-write head and then erasure head. Optical disc, CD-ROM, DVD-ROM, Blu-ray discs, as we have seen in the previous slides. They are non-volatile and read-only memory. They are non-volatile, means the contents are not going to be erased, but they are used for only read purpose. It also available on optical discs. These discs comprising mainly CD-ROM and DVD-ROM. CD and DVD difference between, like, CD-ROM, its size is normally 700 MB to 700 MB to roughly about 1 GB. DVD-ROM, it's more than that. The normally available sizes are 4 to 5 GBs. It may be more than that. Here, the sizes between them varies between 700 MB to 8.5 GB. The Blu-ray disc enhances its capacity to 50 GB. A laser beam in their drives controls the read and write operations. Because most PCs and laptops have these drives, not Blu-ray though, data backups on optical discs are easily distributed. Flash memory. This class of devices having no moving parts, it's based on EEPROM, flash memory. Okay. You have seen, I think, pen drives, flash memory. It's a type of flash memory. It's available in two forms: pen drive, solid state disk, SSD, SSD, and the magnetic card, SD card. Okay, SD card. SD card probably you have seen in your smartphones. Okay, they are portable, need little power, and are quick, and quite reliable. Reliable means you can depend on them because they are permanent storage. You can depend on them. You can take out, you can insert, you can share the data. You can do many more things. There you can depend on the data being stored on flash memories. The memory stick or pen drive is the most common type of flash memory used on the computer. You can plug and play type of devices. I mean, you can plug into your system. You can store or retrieve the data being stored inside such memories. It's a small removable piece of circuit wrapped in a plastic casing. Floppy disks. Look at the floppy disk. Look at the hard disk, flash memory, pen drive diagram. Pen drive is also shown as part of flash memory, SD card, SSD, magnetic tape. Look at the magnetic tape, hard disk, floppy disk. Floppy disk, it's obsolete now. Okay, floppy diskette. To insert a CD-ROM, you must have a CD drive available in your system. Similar to that, during our education, I mean engineering days, we had systems that were having floppy drives to insert the floppy diskettes. But probably you have not seen the floppy diskettes and floppy drives. Floppy, I mean 4 to 5 inches around. The size of each floppy disk was around 4x4 or 4.5 into 4.5 size. It's been written here. Look at the floppy was available on two sizes, 5.252 inch and 3.5 inches, offering capacities of 1.2 MB and 1.44 MB. We were using, in most of the time, we were using 1.44 MB. Okay. This storage medium is represented by a rectangular plastic case, a plastic case containing a thin magnetic film. Okay. So in today's class, I have discussed, hope you can able to, I have discussed central processing unit. In today's class, I have discussed central processing unit, its components like ALU, control unit, special purpose registers, clock, then main memory. Main memory, it's divided into two parts, primary memory and secondary memory. Fine. In primary memory, RAM, read-only memory, cache memory, and CPU registers. These are part of the primary memory. Fine. All of these components have been included. They constitute primary memory. Okay. In RAM, there are two types, SRAM and DRAM. ROM, different types of PROM, different types of RAM or PROM, EEPROM, cache memory. Okay, there are different levels of cache memories like L1 cache, L2 cache, L3 cache, and apart from that, registers are also part of memory. They are divided into two parts, general purpose registers and special purpose registers. General purpose registers are very few in number. They are used for storing intermediate results during the computation of your program. Secondary memory. Secondary memory includes hard disk, magnetic tape, CD-ROM, DVD-ROM, Blu-ray disc, flash memory, okay, and floppy disk. Hard disk capacity is normally 500 GB to 1 terabyte. Magnetic tape. Current technology supports around 1 terabyte or more. Optical discs. Optical discs, I mean CD-ROM, DVD-ROM, Blu-ray disc, flash pen drive. It's a form of, it's an example for flash memory, a solid state disk, SSD, magnetic card, SD card, floppy disks. So these were the contents what I have discussed in today's class, and please go through this material, this recorded material. Along with this material, you'll also get some notes. I'll share it, and we'll also get the multiple choice questions for this class. 10 questions you'll get. Try to answer, though multiple choice questions include answers. Answers are provided at the end, but don't look into the answers. please try to answer the questions by yourself. That helps you to become better and better. Okay. So thank you for listening to this class, and I will continue with the next topic in the next class. Okay, if you have any doubts, you can please you know contact me at any point of time. Please keep your syllabus, uh, question papers of previous years, textbooks, okay, and have a constant touch with the material. And still, if you have any doubts, you can ask me. So whatever I can able to explain within 1 hour related to these concepts, have done my part. And if you still have any doubts, you can ask me at any point of time. So thank you for listening to me, and I will continue in the next class. Okay. Thank you. Thank you very much.